All right. Okay, so as you can see from this week's content today, we're going to completely change gears. We've been talking about rigging for the last 8 weeks. If you've hated that module, we're done with it. We're done, we're moving on. So if it was a struggle for you, your day has come, because we are fundamentally moving on to a different subject matter. So you can forget, well, don't forget it, because you are going to have to do some more rigging later on in the semester. And it's really important stuff, as a whole too. So don't just completely, jettison that stuff from your brain and move on to something else. There's a lot of really good stuff in there. In addition, you're going to be expected to rig something, a component, in your final project. So you really can't forget all of this information, because it is going to be something that we're going to continue to work on throughout the rest of the semester. I've been very open and upfront in saying that the conversation that we have about rigging is not the entire conversation, okay? I probably have scratched, and I'm not joking here, and this is not a hyperbole, I've scratched probably about 10% of the rigging conversation, okay? It's deep. It's a very deep conversation, more than what we can explain in a couple weeks, more than what we could do in probably an entire semester realistically, to get good at it, to be a real, kind of worthy participant inside that workflow. You have to have a lot of exercise inside of it, okay? Couple of you guys have asked, well, where can I go to find some additional moto rigging awesomeness? And of course, the best place to go and check it out is on the Foundry's website, okay? Now, these are quite expensive, but if you're really interested and you're really kind of dedicated about attacking the conversation of rigging, and if this is something that you really want to incorporate into your portfolio, of course, go to the Moto page on the Foundry's website. And under this Moto training video section, the first 2 titles actually are all character rigging stuff, okay, or rigging stuff as a whole. So there they are. These are fantastic, fantastic learning resources. The Rigging Master course is very expensive. It's about $250, but it's worth its weight in gold. It really is a mind dump, a brain dump by probably one of the most talented character artists and riggers in our industry, okay? He is a master in every sense. His name's Rich Hurry, and he does a really great job of presenting the material. The Rigging Master course is a little bit more holistic. It focuses on the entire rigging system, if you will, with the idea that this holistic approach will give you a really strong foundation, and then you can start applying these ideas to basically any rig that you need to create going forward. The character rigging course right above it is about $100 once you do the conversion into US dollars. And that focuses exclusively on characters, okay? That's all they talk about for a number of hours. And I think it's many, many, many hours on the character rigging stuff. And they drive very deep. I'd say that both of these are geared towards the intermediate to advanced user. Yeah, so 35 hours of rigging stuff, character rigging stuff for $100, okay? That's a course. I mean, you guys pay $150 to hang out with me for 16 weeks. If you wanted to have a dedicated course on character rigging, bloop, there it is, okay? These are advanced tutorials. They really are. They're designed for the intermediate advanced user. So they're going to assume that you come to the party with a certain expertise and mastery of the basic Moto rigging system, okay? Both are excellent. Both are highly recommended, okay? I think the first party offerings from the Foundry do a really great job of covering the topic of rigging. More than I'll be ever able to do. So if you want to continue that crusade, I say do it. There's actually a lot of work out there for character riggers. As you may or may not have discovered, this is not for everyone, okay? And if it's not for you, that's okay. It really is, One of my big picture goals in this entire shebang here is, to help you understand what you're really good at and what you want to pursue. There are very, very, very few people who are generalists that make it in this world, right? Mostly it's just because of interest. Not everyone is interested in character rigging. Not everyone's interested in modeling or texturing or making UV maps. Some people want to just be renderers. Or some people just want to focus on animation, and that is fine. Our industry endorses and kind of puts that idea up on a pedestal. You go to a big studio, and the workforce is very, very, very segmented out, very pigeonholed, right? And you have the 3D modeler crew, you have the UV artists and texture artist crew, you have another crew of guys and gals that just do their character rigging, and they have the animators. I mean, it's very, very much broken out into a whole series of discrete, finite little jobs. So master something, figure out what it is that you want to master and run with it, okay? My goal was to kind of, especially in this class, is to introduce a lot of the other things that are out there, okay? Which dovetails just quite beautifully into our conversation today. This is one of the other things that are out there, dynamic simulations, rigid bodies, okay? So for the next couple of weeks, we're going to focus on the simulation system inside of Modo, and this is where it gets a whole lot of fun. Today, we're going to destroy some stuff, which is going to be cool. We're going to start smashing some blocks around together and ask the computer on basically a root level to make the animation for us. Before we get started, I think it's important that we set some expectations of what this is and what this isn't. This is a way for us to dynamically simulate complex movements and animations. This is not a replacement of the traditional keyframing method, okay? In certain situations, a dynamic simulation is important and relevant and should be applied. But in other situations, the traditional keyframe environment is definitely the one that we want to work in. So this is another tool in your toolbox, okay? This is not a replacement of a 401, basically. A lot of folks, they come into this and they say, I'm going to simulate everything, right? And what ends up happening is they spend 8 hours trying to figure out how to build their sim when it would have taken them like 30 minutes just to hand animate it, right? So this is another tool in the toolbox. It's not a replacement of the traditional animation engine inside of Modo, or for any application that is, okay? What we're going to begin exploring this week, in every sense, is an introduction to the visual effects community. The visual effects world, here we go. The visual effects world is really ultimately responsible for those fantastic effects that we see every summer on those big blockbuster movies, right? It's a very big industry. Well, I should take a step back. It's not a humongous industry, but there's a lot of work out there. In my mind, that means it's big, right? There's a lot of films that require visual effects shots in one capacity or another. Basically, in my mind, everything that happens during the summer movie months is a visual effects film to some degree or another. It's pretty amazing. Shoot, the Avengers film, the latest Avengers film, that was practically an animated film for the most part, right? I think the only thing that was real in the Avengers was Captain America and what's her face, Scarlett Johansson, Black Widow. Those are the only thing that was real. Everything else was fake. I'm pretty sure Iron Man was fake. But it's a fantastic industry. This is actually where I got my start in the visual effects industry, okay? Doing some 3D modeling for some effect shots, which is really kind of cool, right? There are some very large players in this world, very large players. And of course, Industrial Light and Magic being the largest player in this industry, which just happens to be in our backyard in San Francisco. So look at this stuff as we explore it. This may be a nice kind of, path for you to take. Not everything is Pixar. Not everything is the game world. There are other opportunities out there that involve some of this stuff. The rigid body and soft body dynamic simulation stuff inside of Modo is quite good, but it's not the only player on the block. Our conversations over the next couple weeks is going to be kind of a general approach. We're going to lay some foundation level ideas with the idea that hopefully you'll take the ball and kind of run with it over the, once you leave here and go off to do other really fun things, okay? There's some applications that are dedicated towards this type of stuff. I think the components and the libraries that we have available to us here in Modo are quite good, but that's not to say that they're the best in the industry. There are other ones that are laser focused on doing hard surface and soft body dynamics. We have two things that we're going to be accomplishing this week. We're going to talk more about these in detail as we get into it. Your homework assignment is going to be a brick wall in which you will smash a ball through a brick wall. We'll come back and talk about that here in a minute. Okay? We're also going to have a fun lab assignment, which is going to get our hands dirty a little bit. And it's going to be a bowling lane. And as one might imagine, we're going to go bowling. Bowling for dollars. Okay? So we'll take a bowling ball and smash it into a whole bunch of pins and see what type of really cool movements that we can create. So those are the expectations. Those are the 10,000-yard kind of ideas that we're going to be discussing this week and next week, okay? Both the brick wall and the bowling lane are going to be due by the beginning of our next class period. Next week, we're going to look at some other things inside of our workflow that are really critically important. Questions, comments before we get cruising here? All right, excellent. If you've downloaded this tree start, we may get to this, we may not. Yes, ma'am. So we're not going to be talking about the green today? Nope. Done with the green dude. Moving on. Finished.
Yeah, because this week I had some trouble with the green dude, and I tried asking Sean and what's his name, Cody,
Mm-hmm.
and they said that they've never really learned that, so it was really difficult.
And it's one of those things, I know Sean's learned it because he was in my last class. So often what happens is that people forget this stuff pretty quickly. If you don't do it every single day, you forget it. It is like being an engineer. It really is. You have to come at it with that mindset. You are building a little robot on the inside of your characters, and time and distance away from that thought often create cobwebs and forgetfulness. So I think that's probably the problem. Yeah. This is my big challenge here on campus, is that there's only one of me. As much as I love our student tutors, they don't have the grasp of all things at the same level as I do. So our student tutors do the best they can. They really do. But this is probably the largest challenge that I have on campus, is that just supporting you guys outside of class is tough. It's tough. So find me, office hours. I have office hours every single day. Please come find me. I'm here to help. During office hours, I can sit with you for an hour and a half every day and just kind of bang through it. I'll spend as much or as little time as you need to resolve your problems. Okay. So back to the tree start. We may get to this. We may not get to this. This is kind of something that I want to talk about and begin to explore it today. So if you've downloaded it, just keep it on your desktop. If we have time and the energy, we'll talk about this a little bit more directly later on. Okay. Let's jump over to Modo. I'm in a brand new scene file here. It's empty, and I want you to play along and follow along as much as you can. As I've mentioned many times before, the best way to learn this stuff is to physically get your hands dirty with it, and to jump in and start building these project files along with us. We're going to start with a very simple little scene file here, okay? So that we can learn the basic components of how to set up a dynamic hard surface animation, okay? This is going to be a simulation, so we're going to set a whole bunch of parameters, and then we're going to ask the computer to basically create some movement based on those parameters. And let's do this. I'm in the modeling layout right now, and I'm going to hold down the Shift key and add a plane. Okay, and I'm going to make this just a little bit longer along the x-axis. And once I have that done, I'm also going to return to my unit primitives and hold down the Shift key and add a sphere. Okay. Now it's important that you hold down the Shift key because we want each one of these pieces to be on its own mesh item. As you may or may not remember, the animation system inside of Modo is exclusively an item-based animation system, right? So we're never going to be animating polygons, which in turn means that we have to separate out all of our literal moving pieces into their own dedicated self-contained items, okay? That Shift key is a great modifier when infusing unit primitives because it automatically puts that unit primitive on its own dedicated mesh item. All right, now I can see that my plane here is much too small in relationship to the sphere. There we go. All right, so in every sense, what we are going to do now is recreate the classic bouncing ball animation, right? But this time, we're not going to put any keyframes down. We're going to let the computer do all the heavy lifting for us and make the movement automatically, okay? It's pretty neat. In every sense, that big, long rectangle is going to be the ground, and our ball, of course, is going to be the bouncing ball, okay? Once we have our scene set up, let's go back over into our Setup tab. And as one might imagine, all of our dynamic rigging stuff is going to be found in the Setup tab. So if you hated coming over here during the rigging portion of this class, I'm sorry, you're going to have to come back here again, okay? Pretty much all the dynamic stuff, all the particles, all the rigging things, those are all found here in the Setup tab, or the Setup interface.
Are we making a path?
Huh?
Are we making a path?
A path?
Oh, never mind.
No. Okay. So where we're going to go, and before we get started, it's important to flex the muscle. Do a quick analysis of where all your center points are, okay? I had a habit the first thing that I do before I start assigning all these dynamic tags to our objects, I just go in, just triple check, make sure the center points are where I want them to be, okay? For my sphere, of course, I want to have my center point spindle right smack dab in the center of the sphere. In the plane, it's sitting at the origin. So life is good. I'm happy with that. And now, let's start positioning my little sphere where we want it to go, okay? So I want maybe my little sphere to start over here. The whole idea that it's going to just go bounce, 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 bounce that way, okay? That's what we're after. All right. Do this at the item level. I've seen this a couple times cruising through the lab the last couple weeks. You guys are working at the component level, work at the item level, okay? When you work at the component level, you move the polygons, but you don't move the center point at the exact same time as the polygon, and that just destroys our animations, okay? Okay, let's do it real fast. It's actually pretty easy. Over in our setup interface, down here at the bottom of our toolbar, of course, we have a dynamics tab. And this is where we're going to be spending most of our time today, okay? Actually, almost all of our time today. And you can see that there are a lot of different dynamic elements and tags, as they're called, that we can infuse into our three-dimensional scene. The blue ones up at the top are where we're going to be spending most of our time today, as they will allow us to very quickly create dynamic objects that the computer will move and simulate for us once we hit that little play button. Now, there are basically three types that we need to look at, okay? We have an active rigid body, a kinematic rigid body, and a static rigid body, okay? Each of these are going to be players inside of this dynamic system, inside of this world that's going to be influenced by what's called this bullet time solver, okay? The library of code that physically gets to make things move, okay? An active rigid body is going to be influenced by the gravity that this solver infuses into our scene. So this is where it gets kind of fun, because now we're going to be starting to simulate real-world forces inside of Modo. And I think the power of the bullet time architecture kind of resides in its understanding of how physics fundamentally works. If you've ever wondered how they make buildings explode and have all those little chunks kind of fall off the building, well, that's what we're about to do. We're going to create active rigid bodies that will dynamically move based off of the physical characteristics of our scene, okay? Like gravity and forces, okay? How many guys have taken like a physics class? Oh, good. Almost everyone. Good. That makes me happy because physics is really important. If you haven't taken physics, go take physics. Everyone should have a basic understanding of how objects out here in our real world are going to be, required to move, and so we can replicate that easily inside the computer. So an active rigid body is going to be influenced by gravity, and let's just do it real fast. These are tags. So let me select my sphere, and exclusively my sphere, because I want my sphere to be influenced by gravity. With the item selected, I can return over here to my dynamic tools and choose active rigid body. Now on the surface, it doesn't look like anything has really changed, but upon inspection of our item list, you can see that we've added a new element into the mix here, the solver. And if you look very, very closely, the icon is kind of hard to see, but it looks like the chamber of a revolver, right? If you look at it from the sides, it's supposed to be like each of the chamber, okay. Because it's the bullet times, architecture. The bullet time architecture is pretty powerful. I want to say the bullet time architecture of physics was created by the guys down at Weta, but I may be wrong. That's the visual effects crew that most famous for the Lord of the Rings, right? So we have a new item inside of our item list, and this item, if you will, think of it as the only item that's going to insert gravity into our scene, right? It is responsible for having all of the other tagged items understand the physics of our three-dimensional world. Without it, nothing's going to work, okay? Of course, when we select our solver, we're going to be presented with a whole series of options. We'll come back and talk about some of these later, but I want you to just look at gravity for a second. Gravity X, Y, and Z. Now, for those of you that have taken a physics class, this is probably a little bit more familiar, right? Because in that physics course, you had a direct understanding of how much force is being pulled down on every single one of us at every single moment of every single day, right? It's that number, negative 9.81. Oh man, I've already forgotten the working units. Is it newtons? I've forgotten off the top of my head. But that's the exact number that we're being influenced out here on planet Earth, okay? Now, it makes sense that it's a negative value. If you think about Earth, everything is being pulled down to the dead center of Earth, right? In my mind, it's kind of like a little miniature black hole in the center of our Earth, and everything's getting sucked down to it, right? We're being pulled down. So with that gravity value, all of our scenes are going to be, or all of the dynamic items in our scene are also going to be pulled down. You can change this, okay, if you want, but don't change it. Don't change it for a while, okay? You can't change it. So if you want to decrease the influence of gravity, that's where you'd go, because it's going to influence every single object in our scene. Okay. All right, good luck. Yep. All right. So we have our solver. We applied the active rigid body tag to our sphere. So let's look at specifically what's changed on the item itself, okay? I got my sphere item selected, and of course we have all its properties over here. Now we have a new one. Check it out. This is the dynamic tab, okay? This dynamic tab has all the physical properties that are associated with this sphere, okay? And there are a bunch of them. We're not going to go through all of them today. One of the powerful things about the Modo Dynamic animation engine is the number of parameters that we can set to customize how this object is going to be influenced by the physical engines and physical forces inside of our scene. But there are some important ones that we'll talk consistently about. The collision category is actually really important because this is going to influence how this object interacts with other objects inside of the scene. So we'll come back and talk about that here in a minute. And of course, the mass, how heavy this object is, and how this number is going to be influenced by the physical forces inside of our environment, okay? So we're going to come back to collision and mass frequently. These others, you can see that we have a lot of different values in here. Some of these we'll talk about. Some of these I'm not even sure what they do inside the system. It's a pretty deep environment, it really is. So we have a lot of stuff to talk about in this tab, okay? Every dynamic item is going to have this dynamic tab. Think of it as a tag, T-A-G, okay? We're basically saying this item is going to be influenced by the environment, by the physics engines. Not all items need to be dynamic. We can both enable and disable this tag, and we can remove it as well, okay? So it's not written in stone. There's always a way for us to escape this dynamic environment if we really need to. If you look over here in our toolbar, well, they may have changed it in 901. They used to have an option that said make undynamic. They may have changed it into our dynamic pull-down menu. Yeah, remove dynamic. So it's in the dynamics pull-down menu now. Remove dynamics. And that's basically going to remove that tag from this object, okay? So I can do it, just remove dynamics, and check it out. That dynamic tab on my sphere is now gone. Let's put it back on. Active rigid body. Bloop. Active rigid body. There it goes. Must not have clicked on it initially. So we're back in action again. All right. So let's see exactly what this thing does, okay? We've added a dynamic tag, an active rigid body tag to our sphere, and let's begin simulating this movement. In the setup tab, have you always wondered why we have our timeline down here? That's for all the dynamic simulation stuff in this layout, okay? Now for us, of course, we have the play button, which is going to be an important factor going forward, but right now, we haven't actually asked the computer to create any dynamic information for us yet, okay? These three buttons over here are really important, okay? These three buttons, the hollow play button, and this last one that looks like a square with an arrow, are going to allow us to preview and then cache our dynamic simulations inside of our timeline.
So are we going to be adding a dynamic to the floor also, so that way it, creates a collision?
Absolutely. Absolutely.
I just didn't play it.
It went right through the floor, right? So it's important to understand the role of each of these buttons because they have very, very different roles. So the first one, let's just do it real fast. If I hit the first one, check it out. Woo, there goes our ball, right? Now, that first one, if you notice, our playhead and our timeline hasn't moved at all. That first one's going to give us an unlimited preview of the entire dynamic simulation. This is going to be really important here, not next week, but the week after, when we start talking about particles. It's a great way for us to see how our little smoke and our fire and our explosions are being crafted in front of us. Okay? So it's an infinite. The sim is still going, actually. The computer is still trying to figure out the math to make that sphere move. And if I was to orbit my camera down some, you'd see that sphere still falling infinitely inside of our universe. Whenever we're working and have our dynamic sim running, it always gives us this little HUD here that exposes a number of chunks of info for us. So it's a good little kind of thing to keep in mind, just so you know when it's running and when it's not running. Let me hit the stop button, and you can see that thing goes away, and my sphere returns. So the play button is just going to infinitely go, and it's never going to stop. I bring that up because the middle button is going to honor the range of frames that you've set inside of your timeline. So if I hit the middle button now, check it out. Now the playhead moves. You can see it going, and then once it gets to 120, it's going to start over again. Okay? This is really important because now the rest of the animation, let's pretend that maybe we have other animated elements inside of our scene, are going to be fired off in the timeline. Anything that's timeline driven is going to be honored and played as well. That first button is basically going to just do the dynamic elements only. Okay? So if you had other keyframed animated elements in the background, that first button ain't going to do nothing. Okay? Yeah?
So I got to think, so whenever someone makes a CGI building, so I mean, it's obviously made out of multiple meshes, almost like Legos, correct?
Mm-hmm.
We're going to blow it up.
Yep.
I didn't think about that before. I didn't know that.
Yeah, that will come a little bit later. We're actually going to blow up a building. Yeah, it's pretty fun. That's going to come next week. We have to take kind of a baby step first before we really start jumping in to that advanced stuff. And to give you a little preview, procedural shatter. So we'll blow some stuff up later. Okay. Okay. So the last one, and check this action out. It's going to happen in about a blink of an eye. You're probably not going to see anything. But this last button, get out of here, Doc. This last button is actually going to run the simulation and then save all of that information back on our timeline. Okay? The first button is just going to give us an infinite preview. The second button is going to give us a preview of the timeline, but it's not going to save any of that information to the timeline, so I can't go back and review it. The third button is going to save it to the timeline. Okay? So, I didn't even hit anything, and I got the beach ball. Bum, bum, bum. Come on, little computer. I didn't even do anything. I just put my mouse over. I didn't even click. Yeah, and it crashed. Awesome. It doesn't like my attitude today. That's got to be it, right? Yeah. The guys down at the Foundry are like, oh my gosh, Pat's live streaming today. Let's make it more difficult for him. Yeah. I was actually surprised. I think it was yesterday when I was live streaming my animation class, I noticed that 3 people were watching it simultaneously, and almost everyone was in class yesterday. So I was like, I wonder who's watching me right now. Kind of interesting. All right, let me just remake this real fast. Luckily, it's a pretty wicked simple example. Yoop. Okay. Let's go back into setup. We'll start moving these things around real quick. All right, and now let's reapply that active rigid body tag to my sphere. This time we're gonna hit that last button, okay? That last one down there, and it's gonna run the sim and then save that information to the timeline. You can see that you can do the entire timeline or just portions of it. This is really nice. Okay? Because in complex animations, your sim time is gonna be intense. It's going to be intense, okay? we just have a simple ball falling in the scene, you probably won't even see the progress bar. Let's do it. Yep, didn't even see the progress bar, right? It was so fast it just evaluated, but check it out. Now that we've saved all that sim information to our timeline, I can scrub through my timeline and kind of get a better understanding of what's going on, okay? So that last button will allow us to use the timeline like we normally would inside of that animation engine. Even now, though, let me select my sphere. Okay. Even with that sphere selected, do you see any keyframe information on the actual timeline? No. Okay. The sim information is temporarily cached, so it's not even permanently saved yet. Okay. It's not permanently saved. If I was to save my project file and quit it right now and reopen it, it's not going to be there. That ball isn't going to move. This sim information is only available within the session, okay? Within the session. But don't worry, we can permanently save it, but just know that once you put it on the timeline, it's not there until we actually go in and hit a button and say, really save this. Now, we want this. We want this feature because we want to make adjustments to it. We want to be able to go in and tweak our simulation to give us the result that we want. And then when we're happy with it and we're ready to go, then we can bake our sim information down to keyframes and permanently save it in a way that allows us to render.
What happens if Moto crashes between?
Oh, you're SOL. You really are. You really are. Now, all of the things that you've changed will be saved, right? So you don't have to go back in and reset up your simulation, but you will have to rerun the simulation again and cache all that sim data. Okay? Yes, absolutely. Because once you bake the sim data, it turns into keyframe, transform keyframe information for that item. So you can tweak it, you can move it, you can make some adjustments to it.
Is it easier to work with it before you do that?
Yes, absolutely.
Okay.
Yeah, for sure. Because it's going to place a keyframe on every single frame of your animation, on every single channel. So it turns into a beast pretty quickly. But it gives us the flexibility that we need. Okay. So I have a pretty boring simulation at the moment, a very boring simulation. If I go ahead and play it, you can see that my sphere just goes right through the entire world, okay? And in particular, if you look closely here, it actually does pass through the ground plane. There it goes, okay? So the dynamic simulation engine at the moment only understands the physical properties of the sphere. So now we need to start adding other elements into the mix, okay? So that we can create this relationship between a number of different items inside the scene. Let me show you something that's actually kind of fun, okay? And it kind of draws focus to the role of the active rigid body, because this is going to be the most confusing part, is to figure out, well, what tag do I use? Do I use the active rigid body tag or the kinematic rigid body tag? And then there's this crazy one called static rigid body. What? Which one do I use? I have 3 different options, okay? Here in my mind is how I think of it. If I want my object to move, okay, it's going to be an active rigid body. If I want my object to be stationary and kind of receive movement, like the ground plane, I want it to be a kinematic rigid body. Now, a kinematic rigid body can also be keyframed. Yay! Okay? And then a static rigid body is not moving at all. It's not going to be keyframed. It really is stationary, static, no moving. Okay? To illustrate this, let's just assign my ground plane as an active rigid body. Yeah, so I just hit the active rigid body. Yeah, and it's just going to woo. Oh, it should have just fell. Let me see here. Let's go into our dynamic thing. It's rigid. Oh, it got. Nope. That's interesting. It should have just fallen, unless they've made a change in 901, which is likely. Yes, we'll make it bounce here in a second. Collision shape is set to plane. Yeah, they should have just both fallen and both been influenced by gravity. Maybe let's turn off do collisions. Does that change anything? No, it's still, well, maybe they are both falling. We just not seeing them in relationship to the grid. No, they're both stationary, which is, That should have happened, so we'll have to figure that out, why that's changing. Let's turn static off. It's dynamic. It is rigid. That should move. Oof, but it's not moving. Interesting.
Try changing the collision type from plane to something else.
Sure, let's give that a go. Let's do box. Now it's going to hit the outside bounding box. Yeah, no change. Let's do this. Let's go back into dynamics. Let's remove everything. Okay. So that thing is still dynamic. Let's make sure I actually hit kinematic. I may have hit compound rigid body on accident. There we go. Rigid, static, states, kinematic. Interesting. So that just threw me for a loop. It should have just as an active rigid body, that should have been influenced by gravity. I know. Let's make this dynamic, not static. Let's run the sim, see if that makes a difference. No. Okay, well, either way, we're getting what we want. Either way, we're getting what we want. We want the grounded plane to be here. Let's turn the grid back off, and you can see what we got here. Okay, so I actually want my ground plane to be a kinematic rigid body or a static rigid body, because I don't want it to move. So let's actually change it to static, okay? This one's not static, it's dynamic, which is what we want, and it is rigid. Let's preview the sim now, and we're on our way.
If you change the shape from plane to something else,
It'll fall.
It'll fall.
Yeah, that's
Let's do mesh.
maybe plane defaults to like stationary.
That's likely. Yeah, that collision shape may be holding the plane in its current location. Let's see. So I got the plane selected. Let's not make it static. Make it kinematic. Okay, that was expected. Just triple checking. And now let's make it a static rigid body, or dynamic and active rigid body. There we go. Okay, that's what we're after. Okay, or that's what I was expecting to see initially when I started this entire thing, to have both things fall. Everything's active now. Everything is being influenced by the gravity inside of our scene. Okay, so let's change it. Let's change our plane to be a kinematic or a static rigid body, and then it's not going to move. Okay, change it to static. Test it. And the ball bounces on the environment. Rock and roll, that's what I want. Okay? So think of it like this, or this is how I think of it. Active, influenced by gravity, kinematic, and static. Well, kinematic is going to be, it's not going to move, okay? But it's still part of the sim. It has dynamic forces. It's going to be emitting dynamic forces. It's not going to be moving inside the scene, okay? And then static, and kinematic we can keyframe. We can keyframe that still, okay? Static rigid body, you can't keyframe, and it's just going to be stationary instead of our scene. Anna? Yes, so this is the cool thing about the Modo dynamic system, is that we don't have to go back in and change the type. We can actually change the type in the Properties tab, and you saw me doing that a minute ago. So we can turn it from static to non-static, from dynamic to kinematic pretty quickly. Other applications require you to remove everything and reapply it. Here you just say, okay, I don't want it to be static. And then, is it going to be an active rigid body or a kinematic rigid body? That's kind of your options. So much easier, yeah, I know, so much easier, right?
At the tooltip also, for the commands on the left side, it said if you hold down shift, it'll remove the...
Thank you. I remember someone showing me that once.
So if I use a static rigid body and I rotated the plane, would the ball still roll across it?
With the static, yeah, absolutely. Right, absolutely. Let's do that real fast. I think that's a great thing to do. Let's do it real fast. So let's grab my plane. I'm going to rotate it. There we go. Okay.
It's live. You can use like a paddle.
Yeah, it's cool, right? So there it goes. Yeah, with that first button, yeah, I can actually go in. Let's see if I do it real fast. Oop, I missed it. I missed it. Okay, let's try it again. Oh, I missed it. Okay, let's stop the sim. I want to be ready for it this time. Bloop. Now, for me, has everything to do with my collision shape. Okay, this actually comes to a cool topic here. Actually, let's do this one. Okay, I'm on mesh, which is giving me some problems. Yeah, it's a lot of fun. This is where kind of our world comes to life. It's pretty neat. However, the collision shape should be looked at a little bit because the collision shape properties over there is going to have a direct influence on how each one of these objects are going to be interacting with each other. Now, I have the collision shape set to mesh. We can preview this if we go into our solver and under the visualize, it's debug, I think. Then when we play it, yeah. Then when we play it, you can see the collision shape that we're using inside of our scene. So that little, we basically split our object into 2 polygons, and that creates, at times, especially when things are bouncing on one another, it creates some big issues for us, okay? Because things will bounce through each other. Here's the madness of working with dynamic sims, is that all the participants of our dynamic simulation are influencing the quality of the simulation and the results of the simulation. We have a number of different collision shapes that will influence exactly how this works. I'm going to do box for the sphere, so you guys can get an idea of what this looks like. Here, let's put my sphere over here, and I'll run the sim once more. So the collision shape here has been set to box on my sphere. Boop. Pretty cool, huh? Yeah, so now the simulation is viewing that sphere as a box, and it's not rolling, it's behaving like a box.
Why would it create a rotation around the x-axis if there was no like angle to the plane on that axis? You know what I mean? Like it seems to rotate around, but there's no actual, it's like a false rotation.
So where? Right there?
Yeah.
So that has everything to do with the surface characteristics of this dynamic item. Right now, all of our objects are smooth. We can make them real rough too and coarse, which will change and kind of start to remove some of those movements, the local movements of the sphere as it slides down the plane. So we can change that. But this collision shape thing is definitely something that we're going to want to look at because it has a direct impact on, on how our objects interact with each other. Now, for the most part, what we're going to want to try to do is match the collision shape with the general surface and the general shape of the object that we're animating. Now, with a ball, a sphere, it's pretty easy. A plane, it's pretty easy. But there are some elements in here that we'll need to look at. Specifically, let's see if I can do it here. Okay, I want to zoom in. Look very, very carefully at my sphere when I hit the play button, okay? Look at the shape. See that white outline? That's the collision shape, right? It's a rough approximation of a sphere. We have another option that gives us the most accurate collision that we can get. It's called mesh, okay? Now it's using every single polygon as that collision surface. This is the most expensive thing to render. And you look at the white ball now. See how the cage is matching every single polygon on the object? This now turns into a very expensive object for the computer to simulate because it's really having to keep track of every single polygon on the surface. So you're going to want to be careful with this. It will give you the best results, but it comes at a price, okay? It comes at a simulation time price.
So we're going to be using this wind right here to, deal with the bowling ball itself?
No. Okay, so I'm going to change my collision shape back to sphere. And let's see here. My plane selected, so it's kinematic. Awesome, looks good. Here, let's do this. I'm curious how this is going to work. I'm going to rotate. My little guy here. Okay, so let's just put this at 0. and we're going to key in rotation Z. And then over the course of, I don't know, 30 frames or so, we'll have it move this way. Cool. And then, here, let's go into animate so we can actually see this stuff. My timeline at the moment. Right now I have, because I was computing my sim, all that stuff is on my timeline. And let's clear the simulation cache. Okay? That way I can see the effects of my timeline. So good kind of tip. When you're working with this last button, as I have, that's going to be permanently saved to your timeline until you redo the sim, until you run it again, or until you clear it. Dynamics tab, and then clear simulation. And you can also see save simulation, cache simulation. We're going to come back to this a little bit later. Now, I think a rotation value of 30 degrees is too much. Let's do 15. And then over the course of the next 60 frames, we'll go 15 in the other direction. Cool. All right. I'm actually going to go in and change the post behavior. Oops, I didn't want to repeat. I wanted to oscillate. There we go. Now it will just do that movement forever. Cool. Let's go into setup. Let's run the sim and see what we get. Okay. Nope, don't get much movement. Woo! Yeah, it starts to change its direction if you look very closely. Right in there, it slows down and then keeps going. Okay, which is pretty cool. The weight of the ball, yeah. If we were to change the weight of the ball, well, let's just do it real fast. Let's change the mass of the ball and see how that affects our sim. Which actually, that's a nice segue into these out of the collision shape world and into these other factors that are going to influence how our simulation works. Okay, bounce and friction. These are two important things. Every dynamic object is going to have a bounce and a friction and a stickiness value associated with it. These three channels have a direct influence on how our objects are going to move and interact with each other. Okay, and there is a relationship between them. Okay, because right now I have the sphere selected, so the ball is selected. So I'm changing its local stickiness and its local bounce. But I'll also have to do the same for the plane itself too. So it can turn into a lot to manage, but it's not too bad. So the bounce, this is how much of a bouncy ball it is. Okay, if this was put to 100%, it's going to be like a rubber ball. If you put this to 0%, it's going to be like a bowling ball. It's not going to bounce at all. Okay, or it's going to have very, very little bounce. Friction, this is kind of the smoothness of the object, right? At 100%, it's going to be like sandpaper, and at 0%, it's going to be like a piece of glass, okay, or an incredibly, incredibly smooth surface. So it's going to have zero friction. And then the stickiness, in my mind, this is kind of, imagine that there's kind of like a little glue that's placed around the surface of it, and that determines like the adhesive qualities of that glue. All right, so let's just let's see. I got the sphere selected, right? Let's do this. I want to increase my bounce to 100%, and I'll redo the sim. This will be fun. Boom, boom. Bounces a little bit more. You know what? Maybe perhaps the animation on my let me clear my sim cache here. Maybe the animation on my plane is mucking up this thing a little bit. So let me just go in and get rid of all these keyframes. Okay, let's run the sim now. Boop. And I'm also going to go back and turn the debug visualization off for my solver so we don't get those weird lines. Awesome. Okay. So as I mentioned before, there's a relationship between the ball and the surface. If I wanted to increase the bounce of my ball, well, let's make the bounciness of our plane much higher as well. There we go. Now it's bouncing much higher. Okay, so there's a relationship here. We can't rely exclusively and solely on one object's dynamic parameters to get the result that we're after. Okay. However, we can overdrive these values. Let me stop the sim. I'll go back. Turn the bouncy of my plane back to 35. But on my ball, let's put this like to 300%. Let's see what happens. So we get a very, very similar effect. Okay? There it goes. Because at times, we're going to want to leave the plane's bounciness values as is so that it will affect other elements inside of our dynamic simulation differently. Okay?
So was there a difference between the 100% and 300% you just did? I didn't notice much change.
So I've returned. Yeah, I've returned the plane back to 35, and I put the sphere at 300. So, pretty cool, huh?
Multiply the values and the overall is what affects the bounce.
Yes. Okay. Let's do this. I'm going to take my plane and I'm going to rotate it like this. Okay. And I want to turn the bounciness of my ball all the way to 0. But I'm also going to increase the friction to 100%. So now it should be like sandpaper. Okay. Actually, let's put it back so we have a control. Let's put the friction to 0. Let's see what we get. Player sim. You can see the ball doesn't actually rotate at all, right? It's just sliding away. It's like a very smooth glass surface. Let's do the exact same thing for the plane. Let's turn its friction value to 0 and its bounce value to 0. Let's see what happens. See what we get. Slides away, okay? But now on our plane, let's put the friction value like 200%. See if we can get this thing to stick. Nope, still going to move. Looks like the angle there is probably a little too intense. So let's go back to my sphere and put its friction to like 300%. So now it's like sandpaper. Yeah, and then it stopped. Oh, that was just a cache. But you can see that now this sim is changing a little bit, right? Now, because it's sandpaper, it's gripping that surface and we're getting that rotation. We're getting that roll back. Here it is again. Roll. All right. Now on the plane, I want to increase my stickiness, and you have to experiment with this. All these values are scene specific. So let's just try 50 newtons for the plane. Perhaps not strong enough. Let's put 100 newtons. Yeah, now it's stuck for a second, but I think the weight and the mass of the ball forced it to go. Kind of slowed for a second. Let's put it to something like insane, like 500. See what we get. No effect. So let's do the same thing on the sphere. See if we can get to, let's put it to 500. Oh, mine crashed. No, it didn't crash. It's just so sticky that it stopped. Yeah, this is like glue to the surface. So it's pretty fun. We've got this little sandbox that we get to play in. In every sense, we get to be like crazy puppet masters. Oops. And set up all these parameters and see what we get. And I think that's a good idea to come to this party with. You have to experiment. You got to experiment. You got to try. You got to be willing to kind of fiddle with the values to achieve the result that you're after. Okay.
Is your plane a static or a kinematic?
Mine is kinematic, which will allow me to rotate it and keyframe it if I'd like. Other questions? I see a hand. I want to make sure I don't miss anyone. Okay, so let's keep going here. I think I'm going to, huh? Yeah, go ahead.
Maybe it has to do with because the shape of the plane is a plane, but
Yes, that has everything to do with the collision shape. Yeah, what collision shape are you using, Leland? The plane, yeah. So if your collision shape is on plane, it will be an infinite plane in all directions, and your ball will never roll off. If it's on box or if it's on mesh, like mine was, then it'll know the sides and it'll roll off. Okay, so let me see. Where are we? Okay, let me go back to my sphere. I want to not make it as grippy, and I want to make it pretty bouncy. It puts up to 300. Stickiness I'll put back down to 0. Let me just see what we got. Nothing. My plane is super sticky. Let's put it to 35. Oops. There we go. Now we're getting a little bounce. And over time, the values that we've inserted in the scene are going to do one of two things. They are going to multiply on top of each other because we are passing values from one to another. If you look carefully here, it doesn't appear as though my ball is diminishing in its height at all. And I think you're probably right because both the plane and the sphere have a bounce value associated with them. Those bounce values are influencing each other. And we're almost as if we're never getting lower and lower and lower. So with that said, let's stop this and let's go back to the plane. I'll put this to 0 on the bounce. Let's see what we get now. Nothing. Let's put this down to like 10. There we go. 20. There we go. So you have to dial it a little bit. These things, as I mentioned, you have to come with it with a healthy sense of exploration and experimentation. Just think about those basic principles. The two that you're going to be messing, or the three that you're going to be messing with the most are bounce, friction, and stickiness. Bounce is going to make it more or less bouncy. 0%, no bounce. 100%, a lot of bounce. But we can overdrive those values to get the result that we're after. We're not limited to stay within that 0 to 100% range. Friction, is it like glass or is it like sandpaper? And then stickiness, in my imagination, as I mentioned, there's a little layer of glue that's on every surface, and the stickiness determines that the strength of that glue. With that said, please do not confuse that metaphor with an actual glue value that we can establish down here, so that it is very different. We can actually glue two objects together, and based off their physical forces, they can get ripped apart. Okay, yeah, it's pretty cool. All right. Questions on what we've talked about so far? Is everyone getting a bouncing ball for the most part? All right, cool. Let's kick it up a notch. I want to take my little sphere. I want to move it to the end of one of my rectangle. And now, if I have my sphere selected and return to its dynamic properties, we're going to go down here under the impulse section. Okay? The impulse is going to give it a little bit of a push. Okay? There's two different things that we have to control here. Impulse and force. Impulse is a push. It's a one-time push. So at the beginning on wake, so when we hit that little play button, it's going to push it real fast. In my mind, that's what it's doing. And it only does it once on frame 1. Okay? So we get to choose which axes this push is going to come from and where within that three-dimensional space the pusher's hands are going to be. Okay? So the impulse is going to determine how much of a push, and then the impulse position is where that push is going to come from. Okay? So I want to push my guy along the x-axis. So let's do 10 newtons. Play the sim, see what we get. Oh, went the opposite direction. Positive values over there. So let's do negative 10. And see what we get. Boom, boom, boom. Cool, huh? Let's put mine back down. Let's put it to negative 2. So just a little push now. Boop. Boom, 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 boom. Okay. I don't think my ball has enough. And it doesn't have enough oomph in. I want to give it a little bit of friction so that it rolls a little bit. so it grips. Did it change its angle ever so slightly? I'll need to do the same thing for my plane. Yeah, it's got balance, but it doesn't have any friction. Let's put that friction back to its default of 60, I believe. There we go. Now my ball is rotating a little bit. Okay. So impulse is only going to happen once. Okay. It's only going to happen once. At a value of 0 impulse position. So this over here, at a value of impulse position over on this side, it's just going to be local to where the center point is. It's just going to push it at the location of the object's center point. But we can offset that. So I can put, if this is my sphere, I can push the pusher, okay, as far back from the x-axis that I want, okay, or even up and down to create a different result. Now, in addition, oops, I apologize for clicking off. Torque, what do you think that's going to be? Torque, yeah, twist, rotation, okay? So I'm going to give it quite a bit of torque on the Y, so it should spin like a top. Okay, with it selected. Sometimes it's easier to see the effect when you have it selected, so you can see the center point spindle. Yeah, can you see it spinning like a top on mine? It's pretty cool, huh? I'm going to do the exact same thing. This time I won't do it on the Y torque. Let's do it on the Z torque. Let's see how that influences it. This will be fun. Check this action out. So I'm impulsing it. I'm pushing it. Yeah, go away tooltip. I'm pushing it along the negative, but then I'm also spinning it backwards along the positive. This will be interesting to see the type of rotation that we get. Cool. There it goes. It's way too intense, though. Let's put it to 2. There we go. Now let's see. It may actually come to a rest. No, not before the end of my animation. So we have a lot of controls here. Okay, a lot of controls. Now, I don't want you to confuse impulse with force. Because impulse, as I mentioned, is just going to be a little bit of a push. It's like as if someone has come up behind my sphere and just pushed you real fast, one time at the beginning of the animation. Okay? And you can determine when you want that impulse to happen by going in and adjusting the values underneath this pull-down menu. Force, oops, let's close it.
So you could do a continuous.
Yeah, and I apologize. Force is, I was thinking, the impulse. This used to be instead of force, and I remember that they changed it in 901, so I apologize for that. Continuous, then it's always going to be pushed. Okay, it's always going to. It's not a one-time deal anymore. It's going to get that force along its entire lifespan. Now, check it out. It's still getting pushed and turned. That's actually kind of a cool movement. Cool, huh? You can really see the effect of the torque. Let's do this. Now that we're using a continuous torque effect, let's put this something higher, like 10. You may be able to get this thing to hover. Nope, it just goes different effect now. Yeah, which is, remember that this is all the other dynamic elements inside the scene are influencing the movement. So it could be the torque, could be the plane, could be something else. For mine, it's having a big impact on my movement. Big impact. So you can see it being pushed, and then because of that torque value, I'm getting a rotation value going in the opposite direction of the movement. So it's actually pausing. Check it out. It goes boom, and then it hovers here for a second, and then it keeps going. Let's put this to -20. Now, that's cool. Look at that. That's crazy. Now there's so much torque going in the opposite direction that it can't help but spin backwards. Or you can actually turn all this off if you want and just have it fall. Whatever you like. Good times, huh? I could do this all day. It's just like a little toy box. It's like the goat simulator, right? Right? It's exactly what it is. It's like the goat simulator. Okay? It's a lot of fun. Mm-hmm. You can control Z, yeah. Yeah, that's to go back to the previous values that we were talking about, Vanessa. To reset the entire thing, to get it all the way back to its defaults. You could, but there actually may be a reset button in here. Let's find out. Let's see. If there's not, if the guys down at the Foundry are listening, that might be a good thing to add. A reset dynamics. Huh? Well, we don't want to delete the solver, right? Because the solver basically infuses gravity, but all those dynamic tags are going to stay there. So maybe the easiest thing to do, if you really want to reset it, and this is not ideal, but it is a way, you can remove the dynamics from that object, make it undynamic, and then make it dynamic again, and all those values are back to their original positions. That's a way of doing it. Let's see what we got. Let's make mine more bouncy. And let's also give it a little bit of a push. Awesome. In that, we have now just recreated the classic bouncing ball exercise in about 10 seconds, right? Bong, 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 bong. Pretty neat, huh? Pretty neat. Okay, questions about what we've talked about so far? All right, I'll tell you what, let's take a break. I've been yakking for about an hour and a half. Let's just take a break, okay? All right. Okay. So I have just a brand new Moto scene file here, and I want to start talking about how we can use the rest of our Moto engine to give us a really cool dynamic result. And this is really kind of directly applicable to what you guys are going to be doing for your homework this week, is you're going to be basically breaking down a wall, okay? So how do we efficiently do that in a way that gives us the most compelling result, but also a controllable result as well, okay? Now, if you think about it, if you project yourself into that homework assignment, you're going to have to create a whole series of individual bricks, right? But how we create those bricks and how we're going to render those bricks actually has a little bit of an impact on it. Let's just do it real fast. I want to make another plane, and then I'll make a unit primitive cube. And naturally, I'll go into my plane, make it much bigger at the component level, okay? Okay? Make it much, much bigger than that. Okay, rock and roll. And then if I really wanted to get geeky, I could go in and figure out the exact same size of a brick, but I'm not going to do that, okay? Because it's just way too much energy. However, I am going to use my snapping engine to get me what I want here. There we go. So now I know beyond any reasonable doubt that guy is sitting on the ground plane. If you haven't fallen in love with the snapping engine, you should inside of Moto. It is quite good. Okay, the snapping engine allows us to work very, 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 very quickly. I've shown this to a couple people individually, but it's so important that I'll show it to you, everyone here together as a class. Okay, so I got my plane, and then I got a simple little cube. Earlier, I wanted to just move that polygon that I have selected there to match the exact same height as my plane, right? Now, without the snapping engines, this is still doable, right? This is still this is very easy to do, but it's very clicky. How would I do this without using the snapping engine? To get that bottom polygon right down there at the exact same height as that plane. And let's pretend I don't know what that height value is. Sorry, Anna. She's like, oh, it's not going to work. Any takers? How would we do it? Okay, dust off your GCOM 402 cobwebs. Okay, kinda. So I want to move the bottom of that cube, the one that's selected, to match the exact same height as that ground plane. I never really considered that, but let's give it a try. Now that's going to happen at the item level. Okay, this is just modeling. Don't think rigging. Don't think rigging. This is modeling. Okay, and it's a great illustration of the power of the snapping engine. Okay. So here's what we would do, or here's what I would have done. I would have gone to my plane. I would have selected a vert, okay? Then I would have found under its info and statistics, okay? So stats, I'm over here, here's properties. I've gone to lists, okay? And under info, it will give me the height, the Y value height of that selected component. Mine just happens to be sitting at the origin, which is why it's at 0, okay? And this is what I'd do. I'd copy that value, go back to the other object, grab that polygon, return to my vertex collection of tools, set position, oops, hit the wrong button, set position, a value of 0 along the Y, and then bloop, it would move it up, okay? Man, that's a lot of work, right? It's possible to get that level of accuracy, but there's a process in front of it, right? Well, the snapping engine kind of removes that pretty quickly. And the snapping engine inside of Moto is amazing. It is a humongous time saver, and it's fundamentally changed the way I've worked inside the entire app. So this time we're going to do the exact same thing, but we're not going to go through that crazy process. There's way too much math. There's way too much thinking. I just want to raise that polygon to the height of the ground plane that's sitting in that other mesh item. So I want to turn on the snapping engine. Does anyone remember the keyboard shortcut to enable snapping? X, right. The X key will turn on our snapping engine. You can also click on the snapping button up here at the top, that one. And down here in our tool options, this is our snapping palette. So this is how we get to adjust all the parameters of our snapping. And there's some things in here to look at, okay? Because we can snap to the grid, vertex, edges. I mean, there's a lot of different things in here that we can snap to. And one of the cool things that they're doing now in this version of Moto is that we can save combinations, okay? Because right now this is the preset, but you can make a new preset. Oops. Okay, you can give it a name. and just call this one vertex snapping. Or if you want to do vertex snapping, grid snapping, and enter edge center, you can do all of those, name it as a preset, and then call that preset quickly inside the snap palette. That's kind of neat. I'm just going to do vertex snapping, okay? So my snap engine's on. Let me just grab that bottom polygon. I'll fire off the move tool, okay? Now, note that my action center is set to none, okay? With my action center set to none, I get to place this wherever I want, okay? My tool handle wherever I want to go, including at the location of an existing vert, okay? Now, it should, and I'm going to put finger quotes there, it should automatically place your action center in the center of the selected component, in my case, that polygon. But we can move it to a vert, any number of verts on that polygon that we want. Now, let me zoom out some. I'm going to move it up. And you can see that once it gets to an existing vert, it snaps. You see that it's kind of difficult to see, and for that I apologize. Oops. Whenever I'm zoomed in like that, Moto freaks out. And I think I may have accidentally squished this thing. Is that from the front? No, we're good now. So my snap engine's still on. Then once it sees another vert at that height, see how it snaps? That's pretty cool. Here's what I do to be really sure that it's snapping to the component that I want it to snap to. If you put your cursor on top of an existing component, see how I get that little purple circle over there on the left? Nice visual confirmation that that is the vert that I'm snapping to, okay? I like that a lot because it allows me to move things around to the location of other existing components quickly without having to do, copy the value, set position. So, that was a lot of work. All right, so here is, in every sense, my brick, okay? So, looking forward to the future here, looking forward to your homework assignment, what am I going to need to do to make a wall? Huh? Make it bigger? Yeah, but I want to have a ball, like a wrecking ball, go through that wall, right? I want the compelling animation that we create from that dynamic sim to make it look like we're actually bursting through a brick wall. So what do I need to create here? More bricks, right? I need to have a lot of them, actually, a ton of them, okay, in order to get the result I'm after. And this is where you kind of turn into a little bit of a mad scientist, okay? Of course, this is going to happen at the item level, okay? We need to have separate items for all of this because our entire animation engine is centered around that item level classification, okay? So we can't have one mesh item with 300 bricks in it. We have to have 300 individual bricks, okay? Now, what could we use to make our lives a little bit better? Both the clone tool and instance clones, right? Because that's going to allow us to save some performance on the render time and make some meaningful connections. Let's talk before we go any further about how this is going to work, okay? Especially when it comes time to render these things, okay? If I hit the M key, and let's just call this new material brick. We'll give it a nice kind of brick red color. There we go. Cayenne. There it is. All right. Rock and roll. Now, what we've just done is a polygonal tag, right? A polygonal tag. We selected the polygons on my cube, hit the M key. We're associating with that material with a polygon or a series of polygons. Any polygon that's been associated with that material is going to adopt the contents of that material group, right? That material. If you look at the way this is working, I have selected the material group. And then down here in the Properties tab, this defines exactly what is going to get influenced by that material. And we're using a polygon tag. And it tells us which polygon tag we're using, right? And we can even filter it by item, too. We can say only the brick item is going to get this one, okay? Let's ensure, or let's see what happens when we clone this thing, okay? Now I'm going to do this at the item level. Duplicate, clone. Okay? Life is good. Life is good because the clones, the true mesh clones, also adopt that exact same polygonal tag, which is what we want. Point being, you want to do all your polygonal tagging before you clone things, right? That way everything gets the exact same shader tree information. Let me go back in time one step here, pre-clone, and this time I'm going to do an instance clone. I don't need 10, let's just do 3 again. Okay. The instances also should adopt that exact same material tag, okay? So we're lucky in that regard. We're lucky, okay? Prove it. Render this thing real fast. Come on, hello. There we go. And life is good, right? So we have a whole series of instances. Any change, anything that we do in that world, so if I went and added like, oh, I don't know, if I added some noise in here, all of them are going to adopt that noise, which is exactly what we want, okay? This is the direction we want to head in pretty easily because it allows us to do some pretty interesting global shading quickly across the surface of my entire object, okay? So make the meaningful connection between the material and your object before you go any further, okay? That way, you can do some quick global shading when you're ready to render, and you don't have to worry about going in and selecting each individual one. Now it's just going to be a nightmare, right? You don't want to do that. You don't want to do that. Make one brick, or at least make the connection. You don't have to. You don't even have to touch the shader tree, but just make the connection between, make the poly tag between the polygons that are on that brick and a future material group. So when you clone it, when you duplicate it, that information will also get cloned and duplicated as well, okay? Because what you don't want to do at the end is have to select every single brick. That turns into a little bit of a headache. It's not impossible to get around, but it's a whole lot easier if you think through the process ahead of time, okay? Especially when you're cloning a lot of these, okay? Does that make sense? Okay, one other thing. The cool thing about working with instances, and I'm going to delete mine. Let's go back into the Setup tab. Oops, did I really do it? I selected the plane. Oh no, yeah, I really messed up, didn't I? Oops, I moved the object at the component level away from the center point. That's okay. Let's just do this. Let's go back in here. Let's center this along the XZ, and now we're back, ready to rock and roll. Okay. I have a very big brick. That's texture locator. Okay, great. Okay, so the other thing that will also go along for the ride when you start cloning things, believe it or not, are all of our dynamic tags. Yay, we like that very much, okay? So these are going to be active rigid bodies. The ground, of course, is going to be a static rigid body. And when I start cloning my brick, I'll just do it real fast, those tags and all of their corresponding dynamic properties will also get cloned. Duplicate, we'll do an instance clone. There we go, I'll make it very close, as bricks normally probably would be. And I'm also, save yourself a headache over here. Inside the item effector category of options for the clone tool, change your parent to like hierarchy or at the very least root, okay? That way, all of your instances will get nested and parented to the master brick. Makes life a whole lot easier. And if we look at each one of these, yep, they're all dynamic, which is kind of nice. Each one of the clones have that exact same dynamic tag. Now, this happens at the item level, so each one of the clones at the moment are seen individually in the eyes of the dynamic system. So it's not referencing the dynamic information on the master. We have to control each one of them independently, and let me illustrate that, okay? So if I go up to my brick and change its bounce to like 0, I don't think bricks really bounce all that much, right? And they're pretty sticky. like sandpaper. So I'll put their friction up to 0. Now oh wait, no, they must have changed that. In previous versions, it didn't reference. So that's actually good for us. That's actually really good for us, actually. I like that very much. Excellent. That makes life a whole lot easier. So yay for instances. Yeah.
So even though they're parented, it won't affect the way that they react when you create a simulation?
Shouldn't, but probably the best and probably the safest way to do this, to ensure that they don't get some sort of crazy rotation on it based off of the parent. We can put them all inside of a group locator. Yeah, let's try that instead. So we'll duplicate it. We'll do another instance clone. But this time, is it primary? I can't remember. Oh no, we want to go in the other direction. Hierarchy is absolutely not what we want. And primary is going to put all the instances inside of a group locator. So let's do off, and then probably the best way to manage it is to take all of these guys and put them in a group locator. Group locator, which is a fancy word for folder. There we go. Now, as long as we don't touch the group locator, we don't rotate the group locator, it won't affect its contents. So the dynamic simulation should continue to work the way you think it would. Okay. Pretty cool, huh? Pretty cool. Don't forget that little shading bit. Okay. I've had some people turn in project files where every single item has its own material group, and you're like, no, time out. Do the connection to the material group first, then all that information and stuff will go along for the ride. All right. Oops. Let's look at the scene file that we're going to use for our bowling lane. I already have it downloaded to my machine, but it's yours to have. There we go. Please note that there is a texture, okay, for the actual bowling pin itself, okay? There is a texture. I've given you that texture. Okay, there's our bowling pin. Everything is just chilling at the origin of the scene. Now let's walk through the process of creating this simple little animation. What are we going to do first? Set up the pins. Yeah, I only give you one, right? So you're going to have to do some duplication in here, right? What type of rigid body are the pins going to be? Active rigid bodies. Yes, absolutely. Okay. What type of rigid body is the bowling ball going to be? Active. Now, what type of rigid body is the lane going to be? Static. Static. In this particular example, or this particular scene file, obviously the lane isn't going to move at all. Okay. The last thing that I wanted to talk about was how to set up your animation so that this pin doesn't fall over. Let me show you what I'm talking about. Let's just do it real fast. I think everything is good to go here. So let's make my lane a static rigid body, my pin an active rigid body. Let's just run this in. Let's see what happens. Yeah, it just falls right through. Okay. This happens frequently when things are touching each other. If I was to take this thing and move it up ever so slightly, and I mean there is like the width of a human hair between those elements, now we probably won't get, nope, still going in, so we'll have to bring it up maybe even a little bit more. Make sure that my dynamic tag here, let's do mesh for my lane, for its collision type. There we go. Now it's resting on there. Oh, and it looks like it's resting well above. Let's grab that. Let's do mesh as well for its collision type. And it's still popping up. And that's because if you look at where it's popping up, Yeah, I have a theory on this as to why it's popping up. The lane itself, we need to change its collision to convex decomposition. That will probably do it. Convex decomposition can and should be used when having like insets, openings inside of your objects. Let's turn on the visualization of our scene so we can see exactly what's going on. So debug, let's run it. Yeah. Okay. Step in the right direction. Let's do this for our bowling pin. Let's change it to hull. See what that gives us. Nope, still going to fall through. Don't make me pull this way up here. Okay, let's run the sim. Sometimes when you run the sim and put it on your timeline, you can actually step through and see where the problem is. It's just fallen all the way through. Let's figure out why. Why is it falling all the way through? So let's set the hull. Let's try box, see if we get a different result. Aha, different result. However, the box is quite large. Wait a minute. Make sure there's not anything else on this mesh item that's messing it up. Nope, we should be good to go. What is going on here? I had a brain fart. There is a way to go in and view what's called the bounding box, which is just the basic representation of the actual object itself. Bounding box. There we go. So there's the bounding box of our object. When you change your collision type to box, or excuse me, yeah, when you change it to box, it should be using the bounding box to determine its collision type. Let's do the same thing for our lane. Yeah, okay. So that makes sense to me. Let's do multi-hull. Turn the visibility of our bounding box back off. Ensure that we're looking at our solver's debug information, and we are. Let's run the sim. And now it's resting on top, so that's not working. So maybe what we should do, anyone want to take a stab at it? Mesh, we can try mesh. Cut up, we're also going to try plane too. There we go. That's what I wanted. It may be. Let's see. Let's go back into the bowling pin. And under its visibility section, let's turn off bounding box. I'll run the sim just so I can step through the timeline and see exactly what's going on. It's dropping way too much. Yeah, it totally is at the moment, which is odd. It shouldn't be doing that. So that means, let's do this. Let's change the lane's collision type from mesh to plane. Let's see what happens. It's making it much, much worse. It should be at, why is it doing that? It should be at the origin. The plane of our, yeah, the plane here is at the origin. So let's debug it. Let's see what's going on. Welcome to working with dynamic sims. It's all about figuring out precisely what the computer's doing. Okay. So there's the plane. Now I think I know why that's going up there. Let's zero out our transforms. Maybe that plane will go to a new location. And it sure doesn't. Center point of the object is on the lane itself. It's way down here. So that was my understanding, that it was. But now I'm second guessing myself. There's the bowling pin. There's the lane. Here, let's do this. No, still going way up there. All right, we're going to figure this out. All right. Let's try deforming mesh. There we go. It's still kind of floating. Okay, so let's figure it. You know what may be? It may be the bowling pin. Let's reset its position. It's interesting that the bowling pin wants to believe that that's its location. So I'm going to align my work plane to the lane itself, and then my bowling pin. Let's do this. Let's just do. Don't want to move the center point. We do want to align it, so we'll do set position. Oops, sorry, not set position. We want to do align to work plane. Didn't I select that? Thought I had. Oh, I forgot to shift select the lane. Now the center points will match and align themselves, or they maybe won't. Okay, what am I not doing correctly here? Yeah, no, because I'm just trying to get the items to move. Let's just do match position, that one on that one. That is an indicator of something. It may be because they're already dynamic. Here, I'll tell you what. Let's do this. I'm going to revert back to the original project file, and let's get this dialed before we start making things dynamic, because I'm having a hunch that it's probably influencing the final design on this. Okay. And here I was thinking that I was being extraordinarily careful, and I was. Look, the center point's right where it needs to be. So I'm not crazy. I'm not crazy. Yeah. The pin is center point's right there where it needs to be. It's on the plane, the exact same location as that guy, which is at the middle of the y-axis. Okay, what we can do is zero out the transforms on the lane and the bowling pin. That looks good. That may have had a direct impact on the setup of all this. Let's see. So this is going to be an active rigid body. This is going to be a static rigid body. Let's run the sim as is. They should fall through. They do. Awesome. No, that's expected. When they're like touching each other, you often get that result. Let's try it again. Now it forces itself through. Let's look at the shapes, the collision shapes of all this. Let's do mesh on both. I didn't do mesh for the lane. And it pops up. It shouldn't have done that. I did earlier, but I want to try it again here in a second. Mesh and Let's give it a try. You know, at this point, I think exploring all options is a great thing to do. Oops. There we go. No, same result. Same result. So there's something in our system here that's causing it to kick up our object. Don't you love computer graphics? Makes you want to do this for a living, right? So what is not set correctly? Let's compute the sim. See if we get anything different. Nope, pops back up. Pops back up and does a little dance. Does a little dance, and then it kind of settles. Let's turn the visualization on. Let's do this, and this is just an experiment. So inside of my lane, basically going to take everything but the ground. I want to put it on its own mesh item. Let's see if that influences this. Nope. You got yours to work? Yeah, that's all I want. Yeah, I can't do that on mine. Huh. Chris, how'd you get your result? So you're not doing collisions? No, yeah, you need to do collisions because otherwise just. Yeah, great. Yeah, that's literally what I have. Bowling pin zeroed out. Lane is zeroed out. Yeah. Ugh. I'm almost to that point. Yeah. All right. What am I missing here? I'm missing something. All right. Okay. Let's see. Aha, okay, so it has everything to do with the collision shape, because when I change the collision shape to sphere, boop, I got exactly what I was expecting to get. So the mesh collision shape, there's something in that mesh collision that's not allowing me what I want. When it's set to multi-hole, big time problem. When it's set to, let's just do hole. Do I get what I want? No, still floating. Sphere has been the only one that works. Okay, other thing that I'm going to do to entertain my thought process here, I'm going to subdivide my lanes. Okay, physically adding more I've seen this before where when you only have like one polygon, things break pretty quickly. Okay. No, still floating. Okay, let me think about this. Maybe it's the margin. Okay. Welcome to the wonderful world of making it work. Okay? This is the wonderful world of making it work. There's actually a real world application to this. Okay? Here's what we're going to do. we're going to make a hack. Okay? We're going to hack this thing together. Okay? When you're out there in the real world, and I hate to say that I've actually done this before, my old boss usually gave me a really hard time about this because I'm doing exactly what I normally do. I troubleshoot the problem, right? I try to figure out what exactly is going on. What's broken? How do I fix it, right? When really the answer to our question is, how do we get the result that we're after? Okay? How do we hack it to get the answer that we need? Okay? What are we ultimately trying to do here? That's the result, right? We're trying to get a bowling ball to knock the pins. The model itself is giving us problems, right? So what if we created a new model? Instead, what if we just had a single plane? Yeah. What if we had a single plane in here that rests at the position where the bowling ball or where the bowling pin is resting? And then we can move the undynamic lane up to that and create the illusion that it's actually on the lane, but it's not. But it's really on nothing, yeah. Let's see if that works. Let's see if that works. This is a hack. This is totally a hack. Now, I'm doing it on the mesh item that has all my lane pieces in it. And I'm going to change its collision shape to plane. I'm going to go into the lane mesh item and just basically turn it off because it's not dynamic. No, this is telling me that the bowling pin is still the problem, isn't it? It's not the lane, it's the bowling pin. Okay, so what could possibly be influencing the bowling pin? Let's revert it. Welcome to troubleshooting, right? Troubleshooting 901. Okay. Okay, here's what I'm going to do. I'm going to, let's make a test example. So, simple plane, okay, not a complex object like we had last time, okay? Let's reduce it to its simplest moving pieces. That's going to be an active rigid body. That's going to be a kinematic rigid body. If I was to play the sim now, it works. Okay, so it's not the bowling pin, but it is the relationship between the bowling pin and the bowling alley itself, the lane itself. There is something inside of that world that's fundamentally not making this work. Because when I remove the bowling alley from the equation, it works. Okay, so there's something in the bowling alley mesh item that's influencing the bounding and the dynamic elements of my pin, right? Because here it works just fine. Okay. So why don't we just turn the lane back on, remove the visibility of our plane, run the sim, and life is good. Hack. It's all smoke and mirrors. All smoke and mirrors, right?
But don't we want the pins to be interacting with the backboard bowling alley?
In a perfect world, yeah. In a perfect world, yeah. Okay, well, with that said, we can do the exact same thing here, right? Let's keep it simple. What if we made a very, 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 very simple version of our mesh that gives us the result that we're after?
When you pull that up just there, did you extrude it or would you do this?
Did edge extend? Okay, let's run the sim, see if it still works. And it doesn't, so there's something about that extrusion that I did. Well, let's just change the dynamic collision type to mesh. Let's get the exact same result, and the bowling pin pops up. So there's something on We're zeroing in on this, are we not? Okay. My understanding was convex decomposition was going to do it. Even on my new piece, the moment I added up that little bloop, that way my bowling pin raised up off the ground, further giving my brain the idea that it's not the bowling pin, it's the bowling alley. It's the lane itself that's causing the problem. So let's figure this out. Good question. Let's find out. Run the sim. It does. Pops up. Okay. Now I'm hell-bent on figuring this out. It doesn't like the
Constructed out a series of boxes.
Yeah. Wait a minute. All right, I'm giving up. I'm giving up, and here's my solution. I'm going to take that back wall, cut it, and put it into a new mesh that's also going to be dynamic, right? Okay, so now basically I have a whole series of planes. Okay, let's make this one dynamic too. If I run the sim now, it still pops up. The little cusses. This is driving me crazy. Maybe what we'll do is we'll just change the collision shape of our bowling pin to sphere, call it a day. Because that seems to be the only solution that's given us the result that we're after. I know what I'm doing this weekend. I'm gonna figure this out. So that's the solution, I think. That's the workable solution, I think, for our problem, unless you guys can come up with another one that gives us the result that we're after. If you change the collision shape for your bowling pin to sphere, it will work. Now, the animation is not going to be great, because the animation is not going to, it's not going to fall over. Yeah. Is it working? Yeah. See, mine didn't do that. Mine keeps popping up. Does yours pop up? Why is mine popping up? What computer number are you? No, let's check it out. See if maybe there's something we can observe in your scene that's different from mine. Can you go ahead and show me? Yeah, that's it. That's exactly what I want, right? Okay, let's go ahead and stop it and go select one of your bowling pins for me. Let's look at its dynamic tab. Do collision dynamic statics turned off. Yeah, right? Maybe I need to restart Moto. What about your lane? Show me your lane dynamic elements. It's mesh. Yeah, that's what it should be. A mesh should work. Why is it not working? Oh, that's incredibly frustrating. Oh, yeah. I love how we're getting different results, same like scene files, same parameters. The defaults, basically, yours is working, mine's not. That just drives me absolutely crazy. Yeah, I know. Save as. Once you send it over to me there, Cedric. And we'll arrange something when it comes to your grade if you know. No, I'm joking. All right. Okay, so I'm going to run through this one last time because this is absolutely driving me crazy. Okay, so that, static rigid body, bowling pin, active rigid body. Now, without touching a single thing else, it falls through. Okay, let's change the bowling pin's dynamic shape from multi-hole to box. See what we get. Okay, now did you move your box up at all? Like a hair? Yeah, okay. That makes sense to me because that's what I would have prescribed, and mine just keeps falling through. Now for your lane, is you're on multi-hull or mesh? Mesh, okay. And mine still floats. This makes me want to pick up my keyboard and throw it out the window. Okay. Yeah.
Oh my god.
Did you get it? No. It's like, yes! Oh, wait, no, I didn't get it.
It's like I put it up really high, let it fall, and for a second it looked like it was touching the lane, but it wasn't. We haven't even touched the bowling ball yet.
I haven't even touched the bowling ball.
We don't know if it can also the ball.
Here, let's do that. Let's see if the bowling ball will give us a different result here. Okay, so I'm gonna make the lane static rigid body. Okay, where's my ball? There it is. And I'm just gonna put this up here like so. Let's shoot it down the bowling alley. So it's gonna be an active rigid body. Under its dynamic tab, its impulse, we're gonna give it quite a bit on -10. Let's run the sim. Okay, that was not what I was expecting, but it was awesome. Okay. All right. Because I didn't do -10, that's why. There we go. Okay, now let's look what it's doing here. Let's look what it's doing. I'm going to compute the sim, then we'll play it off our timeline. Okay, so I'm giving it way too much oomph. Yeah. And I think I've just given it way too much energy. Okay. I probably should also reduce the bounce of my bowling ball. Let's see what we get. Whoa, 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 whoa. Yeah, it pops up. Why does it pop up? If you look at where it's popping up to where my bowling ball was eventually. That's weird. Let's do mesh. Run it again for the lane. So I'm changing the lane's dynamic properties. There we go. Well, no. Let's see. Okay, so there's something in the lane here that's causing some problems. Oh my gosh. Why? Yeah, that's you also make the density of the bowling ball. We can make it 12 pounds lb. I think is either 12 lb or 12 lbs. I can't remember. Crazy, crazy's good. Let's see what computer number you. It's crazy, crazy's good. Let's see what computer number you. Yes! Oh, that's so awesome. Oh, that's fantastic. How in the world did you do that? Just impulse, huh?
I cut the bowling pin from the mesh and it created a new blank mesh and pasted it into there. I think the center is set at the original location.
For the bowling pin?
I think, yeah, I think its center is origin.
Yep. This is actually going that way. That's awesome. Now, I'm going to go back to mine here. Let's do -5. So it rolls. It's doing what it's supposed to be doing, but it hops up. Okay, I got to figure out why it's hopping up. So it rolls. It's doing what it's supposed to be doing, but it hops up. Okay, I got to figure out why it's hopping up still. Oops. Okay. Seems to be that the sphere collision type's the only one that's not popping it up. Because when I change the collision type to sphere on my bowling ball, it's working as it should be working, right? There it goes. Okay, that's exactly what I want. And I bet you if I let it keep going, it probably would hit the back. Yeah, it did exactly what it was supposed to do. Okay. However, if I do the exact same thing for my bowling pin and also set it to sphere, let's run the sim and see what we get. Yeah, see that's to be expected, right? because imagine a gigantic sphere around it. It's not actually taking its own shape and using its own shape, which is unfortunate because it works otherwise. Okay, what am I missing? I'm missing something here. Oops. Crash. Darn it. So close to. Oh, wait, nope. I'll take it. It's fun. Oh, Mr. Bowling Pin. What if Raphael had a suggestion? What if I put it in a brand new mesh item itself?
Is there a way to snap an item mode?
What do you mean?
Like for items to snap to a create an item mode or something.
Yes. So just turn on. It's gonna happen at the location of your tool handles, right? But just turn your snap engine on.
The alignment of the texture group would make a difference. What is? Because I know it's off the origin until that.
The alignment of the texture.
The texture group shows a locator that's off the origin. I don't know if that would.
Which one? Which texture are you looking at specifically? It shouldn't.
Texture group, like if I hide it, it shows a locator to the left, or if I unhide it, it shows a locator to the left.
Yeah, that texture locator is for the planks. It shouldn't be influencing it. It's just a texture locator. Shouldn't be. However, let's deactivate it. Nope, mine still pops up. What's that?
I think it's the back end of your bowling lane that's making it pop out. Because I separated
Excuse me.
the lane, just the flat part of the lane from it, put in its own mesh item.
Yep.
Remove the dynamics from the rest of the bowling lane, and then just put the other part, the flat part, as a plane,
Mm-hmm.
and it worked just fine.
Yeah. I did that once earlier. Okay. So I'll make this one static rigid body.
When you separated it out, did you include the gutters or just the flat plane bar? Just the flat.
Just the flat plane. Yeah. Yeah, it is now working, doing that exact same thing. It is now working the way it should be working. It's kind of working. My bowling pin's going haywire. They don't want to fall over. Well, see, when I change it to mesh, it just smacks it, right? Still don't want to fall over, right? Let's make it real heavy. Let's make it 50 pounds. Now, let's see. There it goes. Now, but then it pops back up. Huh. Why in the world would it pop back up? Yeah, same with mine. It didn't pop up. Okay. That is interesting to me. Boop. That's fun, actually. It's a really good question. No, why does it keep popping up? All right, here's what we're going to do. We're going to forget about this one. We're going to forget about this one. Because there's something going wrong, something going on in the mesh. There's just something going on. I don't know what it is.
It was cool while it lasted.
It was cool while it's kind of cool, right? It kind of works. Kind of works, but then again, it kind of doesn't work. Huh?
Resetting things.
Right? You know what I haven't done is I haven't reset Moto. Let's see if that actually makes a difference. But we're gonna forget about this one, I think, and just do the brick wall. That one I know works because I've done that one about for like 5 times, like for 5 iterations of the class. That one works pretty consistently. The bowling pin, This is the first time I've run this assignment, and it clearly doesn't work. Okay, so let's just talk real fast about our homework this week, which is going to be.
Hey, it's staying. Is it staying down? It's been.
No, zoom in. Is it really not floating?
Ah,
I don't have it set to active rigid body.
what do you have it set to?
I was just testing it out with the procedural shatter.
Interesting.
It will shatter, but it's not making it shatter.
It's not making it shatter.
But hey,
Not making it, hey, it works, man. It's all at the end of the day, it's just gotta work, right? It's all a hack. It's all an illusion. It's all an illusion. It's all part of the show. Okay, couple things about your brick wall. Okay, 300 frames. Oh, this is actually something that we didn't talk about, and I apologize for this. This is actually kind of critical. We can actually trigger animations. We can tell when to fire off our ball, for example. And I'll do that. Since the only thing in the bowling ball that works is the ball, let's do that real fast. Here, I want to make this plane here. Static rigid body. Okay. And of course, naturally, I'll make the bowling ball up a little bit higher. There we go. Cool. And this is going to be an active rigid body. Now, back on the plane, though, I want to make sure that its dynamic shape is set to plane. Cool. And I'm going to give the ball a little bit of oomph. Let's see along the negative x, -5, or negative z, excuse me. There it goes. Great. All right. So one of the things that we can do in our dynamic world, if they haven't changed it, and I'd be very grumpy if they did, is under impulse on wake. No, they have changed it. Huh. Because there used to be a way. Why would they change that? They used to be on impulse, you say on wake, on key, on trigger, and then off. Continuous is new. But I don't know why they would take that away. It's possible, but now there's no. Well, let's try it. Continuous, it is keyframeable. Maybe we keyframe it to off. Okay, we'll keyframe that value to off. And then on frame 21, we'll do on wake to -5. Let's see if that works. It was so much easier when it was just trigger. Let's run the sim. Since this is a timeline-driven element, we actually have to calculate it. No, negative. Let's try continuous. So on that keyframe, it is off. On this one, we'll do continuous. See if we get anything different. There it is. So it's continuous. There it is. It's continuous. Okay. But then it's going to do it every single frame. So I really wish it was on wake. So I only wanted to give it one oomph for a moment, right? Yeah, I guess that'd be it, right? Yeah. Off, continuous. Man, I'm actually going to complain about that. Or off, excuse me. I'm actually going to complain about that. Oop, I need to rerun the sim. That's the old one. Because that seems like a regression in functionality, in my opinion. Yeah, that's what I want. That's what I want. Okay. So.
But you can have it given it power to like the last second and then turn it off.
Yeah, you got it. You got it. So you get control. It's a little bit easier to understand when it said trigger and keyframe, but I guess it's still the same functionality, just displayed differently, which I don't know if I like. Okay, so trigger at frame 15. So there's going to be 15 frames of no movement on the ball, and then fire it off. Okay. Minimum of 30 bricks. Ball must crash through the wall. The brick wall must be taller than the height of the sphere, so it should be a pretty big brick wall, okay? And then the rest of the stuff is is pretty self-explanatory. Okay, 1280 by 720. You're going to do a full-blown render of this as well. Okay, now to get a really cool look, turn motion blur on. Okay, yeah, turn motion blur on. You can do some really fun things. Okay. All right, questions on what you're going to do for your homework this week? I apologize that our lab was a complete blunder. Actually, in all honesty, I don't think it was a complete blunder because I think we learned a lot about the system. Sometimes when things break, you learn more about the system than when everything just. Yeah, you just gotta kind of mess around with it sometimes and see if you can figure out a workable solution. And I don't think we found that workable solution. Bonus points goes to the person that can fix the problem and then reproduce it here in this classroom. Okay, so you just can't tell me, oh, I had it working at home. No dice. Okay, you have to reproduce it here in the classroom in front of me. Huh? Bring it with you. Yeah. You're more than welcome to turn it in the Dropbox. I won't close the Dropbox, but bring it with you. I want to see it. And reproduce it, yeah. You just can't tell me that it works. It worked at home, Pat. That's awesome. But I want to be able to see you do it here in this classroom in front of me.
Can you believe if the boss told you to do that?
Huh?
If the boss told you to do that?
Oh, man. You know, the guys down at the Foundry have said a number of times in their development comments that, you know, we get bugs all the time. People tell us that things are broken, but we can't reproduce it. So it's as if that bug doesn't exist to us. If we can't reproduce it in our office on our machines, then your own machine is weird, quirky, and different. And anyways, questions? All right, I'll see you guys next week. Good luck.